For a moment, imagine the very framework of the universe, its shape, its limits, even its fundamental nature, suddenly shifting beneath us. That moment has arrived. Across observatories worldwide, astronomers watch in astonishment as new data flows from the James Webb Space Telescope. What once seemed like a stable, predictable cosmos now reveals signs of something far stranger, hints of a reality so profound it may force us to rewrite the very laws that define existence. Recently, the James Webb Space Telescope delivered a cosmic revelation that has sent shockwaves through the scientific community. Hidden in the rotational dance of ancient galaxies, researchers have detected a pattern that defies expectations, a clue that may point to a universe far stranger than we ever imagined. This is the story of the greatest cosmic detective mystery of our time. For generations, astronomers believed that galaxies, those sprawling star-filled islands scattered across space, spun in random directions. Like leaves caught in a galactic breeze, their rotations were thought to be the result of chance, collisions, and the chaotic aftermath of the Big Bang. But as the James Webb Telescope peered deeper and further back in time than any instrument before it, something extraordinary emerged from the darkness. By focusing on 263 ancient galaxies, some born just 300 million years after the Big Bang, Webb's instruments captured a surprising trend. Nearly 60% of these distant galaxies appear to rotate in the same clockwise direction. This isn't just a statistical blip, it's a signal, a whisper from the early universe that something fundamental is at play. If galactic spins are not random, but coordinated, then a hidden cosmic order may lurk beneath the surface of reality. This single observation has triggered a cascade of questions. What force could align these galaxies across billions of light years? Could there be a cosmic mechanism, long overlooked, that steers the evolution of entire galaxies? Or is there an even more astonishing explanation, one that challenges the very foundation of cosmology? Among the wildest yet most tantalizing theories now emerging is the black hole hypothesis. What if, instead of floating freely in an ever-expanding cosmos, our universe is actually trapped inside a colossal black hole? To many, this idea sounds like science fiction, but the evidence is mounting. The shared rotation of distant galaxies could be the echo of a black hole's immense gravitational pull, guiding cosmic matter along invisible currents. If true, this would mean that the boundaries of our universe are not the edges of space, but the event horizon of a black hole, a surface beyond which nothing, not even light, can escape. Inside this cosmic prison, space and time would be warped beyond recognition. The flow of time could slow to a crawl, while the geometry of space itself might curve and fold in ways that defy comprehension. This radical hypothesis has scientists both exhilarated and unsettled. It demands a rethinking of everything, from the origin of the cosmos to the fate of all matter within it. The very laws that govern physics, gravity, relativity, the expansion of space, would need to be rewritten to account for such a universe-scale black hole. And yet, as strange as it sounds, the data refuses to be ignored. But the story does not end here. The James Webb Space Telescope has delivered another puzzle piece: the discovery of so-called sleeping beauty galaxies in the dawn of time. Against all expectations, Webb has identified over a dozen galaxies in the early universe that appear to be dormant, not forming new stars, but lying in cosmic slumber. Astronomers had always assumed that the young universe was a place of furious activity, with galaxies rapidly assembling, stars bursting into life, and energy flooding the darkness. Yet here are galaxies that defy this narrative. Their inactivity suggests that something, perhaps the influence of supermassive black holes or the gravitational tug of neighboring galaxies, has halted the very process of star formation. The stop-and-go rhythm of cosmic evolution is more complex than previously imagined, and the early universe seems to have harbored quiet, sleeping giants alongside its blazing newborns. alongside its blazing newborns. One of the most jaw-dropping discoveries to date is the detection of a dormant black hole in the Orange Galaxy, a behemoth weighing in at 36 billion times the mass of our Sun. Using the mind-bending technique of gravitational lensing, astronomers watched as this invisible monster bent the path of light from distant stars, revealing its presence despite its slumber. This black hole does not devour stars or swallow light in a frenzy. Instead, it sits quietly at the heart of a fossil group, marking the cosmic endgame of galactic evolution. Such giants may play a hidden role in shaping the fate of galaxies, and perhaps the universe itself. The implications ripple outward. If the early cosmos was home to both spinning galaxies and sleeping behemoths, could these phenomena be linked? Does the uniform rotation of galaxies point to an underlying symmetry that only a black hole could impose? Or are astronomers witnessing the fingerprints of processes yet to be discovered? Naturally, alternative explanations cannot be dismissed. Some scientists caution that what appears to be a grand cosmic pattern might in fact be an illusion, a side effect of how we observe the universe. The Doppler effect, for example, can make the motion of galaxies seem different from their true paths, depending on our vantage point and the wavelength of light we use to measure them. Observational bias has long bedeviled astronomy, where the limits of our instruments can shape the very reality we think we see. If these biases are substantial, then the apparent alignment of galactic spins may be a trick of perspective, not a cosmic law. This realization underscores the immense challenge of probing the universe's deepest mysteries. Every advance in telescope technology, every refinement in measurement brings us closer to the truth, but also reveals new layers of complexity, demanding fresh scrutiny and careful skepticism. Still, the bold hypothesis remains. Perhaps our universe is not an infinite expanse, but an interior realm defined by the event horizon of an unimaginable black hole. Recent data even suggests that space itself may not be as flat and static as once thought. Some astrophysicists, poring over Webb's findings, describe space folding like paper, an image that evokes the bizarre and beautiful possibilities of higher dimensional physics. If the universe truly folds in on itself, if cosmic structure is shaped by forces beyond our current grasp, then the next great leap in human understanding may be within reach. The only certainty is that the cosmos is more mysterious and more magnificent than anyone dared believe. And as astronomers chart these new frontiers, they find themselves standing on the threshold of a reality where the unimaginable becomes possible and the possible transforms our place in the universe forever. Across the universe, black holes have always commanded awe, enigmatic regions where gravity reigns so supreme that nothing, not even light, can escape. But the James Webb Space Telescope has now pushed the boundaries of cosmic mystery further than ever before. Its recent observations sent a shockwave through the global scientific community when evidence began mounting that not only do black holes shape galaxies, but that the very universe itself might be trapped within one. This hypothesis, once the stuff of theoretical speculation, now stands at the cutting edge of astrophysics. The idea draws strength from an astonishing pattern: the coordinated, predominantly clockwise rotation of ancient galaxies scattered throughout the deep cosmos. For centuries, scientists assumed that galaxy spins would be random, distributed evenly in all directions. But the Webb telescope's meticulous survey of over 260 primordial galaxies revealed a clear preference: 6 out of every 10 spiral in the same direction, as if dancing to a hidden cosmic rhythm. To understand the magnitude of this finding, consider the scale involved. These galaxies are not neighbors. They are separated by billions of light years and billions of years of cosmic history. Yet, they share a unifying trait. Some astrophysicists suggest this could be the signature of an overarching structure or force, perhaps the swirling, inescapable pull of a universe-sized black hole. If true, the very fabric of space-time around us would be curving and folding in ways we have only begun to imagine. Adding to the intrigue is the discovery of a dormant black hole of truly staggering proportions. In a distant orange galaxy, astronomers have found a black hole estimated at 36 billion times the mass of our Sun. Such a behemoth was only detected through the subtle warping of light using advanced gravitational lensing. This sleeping giant sits at the heart of a so-called fossil group, a relic of galactic evolution where galaxies have merged, leaving behind an ultramassive black hole in a dormant state. The implications of this find are profound. It suggests that supermassive and even ultramassive black holes may be far more common than once thought, hiding in plain sight throughout the universe. More importantly, it offers a possible mechanism for the end stages of galactic evolution. As galaxies collide and merge, black holes grow larger and eventually dominate their environment. Could a black hole of sufficient mass and scale actually fold space-time upon itself, creating an environment where the laws of physics as we know them break down? These discoveries are not limited to spinning galaxies and sleeping black holes. The James Webb Telescope has also unveiled galaxies that seem to defy the cosmic timeline. In an unexpected twist, it identified more than a dozen so-called Sleeping Beauty galaxies, massive systems that appear to have stopped forming stars in the early universe, billions of years before prevailing models predicted such dormancy. This halt in star formation is believed to be triggered by supermassive black holes and galactic neighbors, which heat or expel the cold gas needed for new stars to coalesce. The existence of these ancient, dormant galaxies hints at a stop-and-go pattern in cosmic evolution, where galactic activity can be switched off long before the universe's adolescence is complete. It also raises compelling questions about the interplay between black holes, dark matter, and the cycles of birth and death in the universe. Are black holes simply the end points of galactic life, or are they engines of transformation on a cosmic scale? Yet, as revolutionary as these findings are, scientists remain cautious. The possibility of observational bias cannot be ignored. The Doppler effect, for instance, can distort our measurements, making galaxies appear to spin in one direction more than another, depending on their orientation relative to Earth. Astronomers are meticulously re-examining their data, developing new calibration methods, and planning even more precise surveys with future telescopes like Euclid and the Nancy Grace Roman Space Telescope. The stakes for cosmology are high. Should the black hole universe hypothesis prove accurate, it would rewrite the most fundamental principles of physics. Einstein's general relativity predicts that inside a black hole, time and space can fold and twist in unimaginable ways. If our universe exists within such a fold, essentially inside the event horizon of an ancient, universe-sized black hole, then everything we know about the Big Bang, cosmic expansion, and even the ultimate fate of the cosmos would need to be revisited. This line of inquiry has already sparked a flurry of theoretical work. Some researchers propose that what we perceive as the Big Bang might have been the birth of a new region of space-time, emerging from the collapse of a previous universe into a black hole. In this model, black holes are not just cosmic endpoints, but gateways, crucibles from which new universes might emerge, each with its own set of physical laws and constants. Parallel to these theoretical advances, the practical tools of astronomical discovery continue to evolve at breakneck speed. Gravitational lensing, for example, has become a powerful technique for probing the invisible. By measuring how the gravity of massive objects warps the light from background galaxies, astronomers can map the distribution of both visible and dark matter and uncover hidden black holes that emit little or no radiation. The James Webb Telescope's infrared vision has now revealed details that would have been impossible for previous generations of astronomers to imagine. Its ability to peer through cosmic dust and look back in time to the universe's first few 100 million years allows for an unprecedented census of galactic life cycles, black hole growth, and the assembly of cosmic structure. Meanwhile, the discovery of galaxies out of sync with their cosmic era, the so-called sleeping beauty systems, poses new riddles for astrophysicists. How could such massive galaxies have run out of star-forming material so early? What role did black holes play in shutting down their stellar nurseries? And could these processes be linked to the larger-scale cosmic patterns now coming into focus? As scientists grapple with these questions, the concept of space folding like paper, a metaphor once reserved for theoretical physics classrooms, now seems eerily literal. Data hint at structures on the largest scales that do not fit neatly into the standard cosmological model. If space-time itself is warped by forces beyond our current understanding, the search for answers may guide us to the very edge of scientific possibility. Scientific possibility. In laboratories and observatories across the globe, teams are already preparing the next generation of experiments and missions. New telescopes will soon scan the sky with even greater sensitivity, seeking out the faintest echoes of cosmic history and the subtle fingerprints of new physics. The quest to understand whether our universe is an island adrift in a sea of black holes or itself a cosmic nesting doll continues to drive fundamental research. At the heart of this effort lies a simple, profound truth. Every new window we open onto the cosmos reveals deeper mysteries and richer complexity. The discoveries of today, galactic rotations, sleeping giants, and the folding of space, set the stage for the revolutions of tomorrow. And as we refine our instruments and sharpen our theories, we draw ever closer to answering one of the greatest questions of existence. What, if anything, lies beyond the cosmic horizon? As we look back on these remarkable findings, it becomes clear that the universe is far stranger and more dynamic than we ever imagined. The James Webb Space Telescope has propelled humanity into a new era of cosmic discovery, revealing not only the intricate dance of galaxies, but also hinting at structures and phenomena that challenge the very foundation of our cosmological understanding. Let's recap the most astonishing revelations. The detection of a consistent rotational pattern among ancient galaxies, where nearly 60% rotate clockwise, has forced astronomers to reconsider the assumption that galactic spins are random. This pattern suggests the presence of an underlying order or influence, possibly rooted in the very fabric of space-time. It's a finding that echoes through every corner of astrophysics, raising new questions about the forces that govern the early universe and continue to shape its evolution today. The hypothesis that our universe may be nested within a colossal black hole is perhaps the most provocative outcome of this research. If true, this would mean that the observable universe, with its billions of galaxies and trillions of stars, could be the interior of a black hole formed from the collapse of a previous universe. In this scenario, the event horizon, the boundary beyond which nothing can escape, would define the limits of our cosmos, and the strange warping of space-time observed by JWST could be a direct consequence of these extreme conditions. This hypothesis also provides a potential explanation for phenomena such as the uniformity of galactic rotation and the peculiar folding of space observed in deep-field images. If the universe is indeed contained within a black hole, then the laws of physics as we know them may only apply within this extraordinary environment, and the passage of time, as well as the behavior of light and matter, could differ dramatically from anything we've previously theorized. But the story doesn't end there. Alongside these cosmic-scale enigmas, the JWST has uncovered dormant, ultramassive black holes, like the 36 billion solar mass giant in the Orange Galaxy, lying quietly at the centers of ancient galactic fossils. These sleeping titans are relics of cosmic epochs, their immense gravitational influence shaping the formation and destiny of entire galactic groups. Their discovery, made possible by the precision of gravitational lensing, unlocks new avenues for studying the end stages of galactic evolution and the ultimate fate of matter in our universe. Equally intriguing is the identification of sleeping beauty galaxies, systems where star formation ceased unexpectedly early in cosmic history. The existence of such dormant galaxies in the universe's youth suggests a complex interplay between supermassive black holes, intergalactic gas, and dark matter. It points to a universe in which the birth and death of stars and the growth of cosmic structures are governed by mechanisms we are only beginning to comprehend. Of course, the scientific process demands skepticism and rigor. The possibility of observational biases, such as Doppler effects that might skew the appearance of galactic rotation, reminds us that every extraordinary claim requires extraordinary evidence. Astronomers are now meticulously recalibrating instruments, refining data analysis, and seeking independent confirmation of these results before drawing definitive conclusions. This relentless pursuit of accuracy is what drives science forward, transforming curiosity into knowledge. Curiosity into knowledge. The implications for the future of cosmology are profound. If these patterns hold up under scrutiny, we may need to rewrite key chapters in our textbooks. Theories of cosmic inflation, the nature of dark energy and dark matter, and even the ultimate fate of the universe may all come under review. Could our universe eventually collapse into another black hole, spawning a new cosmos beyond our reach? Or will the expansion continue eternally, scattering galaxies into the dark forever? Every new answer seems to generate a host of new questions. Looking ahead, the next generation of telescopes and space missions promises even greater breakthroughs. Instruments like the European Space Agency's Euclid Telescope and NASA's Nancy Grace Roman Space Telescope will soon join JWST in peering deeper into the past and measuring cosmic structures with unprecedented precision. Each of these observatories will help test the black hole hypothesis, search for more sleeping beauty galaxies, and probe the cosmic web for clues about the universe's true architecture. The synergy between advanced technology, creative theoretical work, and international collaboration is driving a golden age of cosmic exploration. The boundaries between astronomy, physics, and philosophy are blurring as we confront questions that once seemed purely speculative. Our evolving understanding of black holes, space-time, and the birth and death of galaxies is reshaping humanity's place in the cosmos. What once felt like distant science fiction, universes within black holes, galaxies folding space like cosmic origami, and the discovery of fossilized giants slumbering in the dark, are now active areas of research, supported by data and debated by the world's leading minds. The more we learn, the more we realize how much remains hidden, waiting to be revealed by the next great leap in technology or the next unexpected observation. As we close this journey through the latest astronomical discoveries, one thing is certain: the universe will never cease to astonish us. With each new observation, we peel back another layer of the cosmic onion, revealing ever deeper mysteries and fueling the drive to explore further. Whether our universe is truly the interior of a black hole or something even stranger, the quest for understanding continues to unite scientists, engineers, and dreamers around the globe. Thank you for joining us on this exploration of the cosmos. If you enjoyed this deep dive into the universe's mysteries, make sure to like this video and subscribe for more content like this. The adventure continues, and we'll be here to share every step of the way.